Hey guys, welcome back. We're going to take up one question from the homework. This is from the handout RLC Parallel. It's Unit 2, handout 3A, and it's question 5. And a lot of times students have questions about this particular one, so I thought I would take a look at with you guys, okay? So, parallel circuit draws 5 amps. Has a voltage of 120, the resistor is 24 ohms, and the inductor is 33 ohms. And then it's asking about the value of the capacitor. So this guy, obviously is an RLC parallel circuit. And this one's tricky because, there's not enough information, right? Well, there is actually enough information. And the best way to see what's going on with a circuit like this is to actually draw it out as real quick, as, there's no drawing of it here. So we're going to make one. So we know it's parallel. We know it's got a resistor, an inductor, and a capacitor. And we know the total circuit current is 5 amps. And we know the voltage is 120. We know R is 24. And XL is 33. And we have XC here, and we don't know what it is. And so, how do I draw any phasors? Well, we can calculate the currents, and I'm going to do that. We'll calculate the currents for the ones we know. So, because we're going to have a current phasor diagram, right? This is a parallel circuit. There's no RL, there's no impedance phasor diagram for this thing. So, first thing I'm going to do is try to calculate the currents here. And IR, guys, is going to be E over R, so it's going to be 120 over 24. I'm going to just calculate that. 120 divided by 24. Looks like this is 5 amps. IXL, 120 over 33. Okay, so let's try that. 120 divided by 33. Looks like this is 3.636 amps. IXC, oops. Don't know, right guys? Not sure what that is. But I total up here is given. I total is equal to 5 amps. So what I'm going to try now, since I'm stuck, is I'm going to try to draw these phasors, these current phasors, the ones that I can, as best as I can. So here's my little phasor world here, and we'll see if we can draw those phasors. We'll start with a purple marker here, and I know IR is going to be on the bottom here. And so we're going to compare all these to the voltage, right guys? So there's IR, and it's 5 amps. And I'm going to draw IXL here, and that is an inductor, so the current's going to go down, and that's what it looks like right there. IXL is equal to 3.636 amps, right guys? And the last phasor that I can draw, well, I can't draw it, but I know where it sits. It sits here and goes up. It's IXC. It's going to go from here up, and I total is 5. Now, if you think about this drawing, there is only one value for IXC that will make the sum of the 3 equal to 5, because if IR is 5 amps and I total is 5 amps, that means they must be right on top of each other. That's the only way, right? So this is I total, guys, and it is equal to 5 amps. There is no other place that I can put I total where it would be the same as IR. If it was up here, it'd be longer. If it was down here, it'd be longer. What that means is IXC, because I total is the sum of the 3 phasors, IXC must be equal to 3.636 amps. And IX, the difference between IXL and IXC is 0. Okay? Now, if IXC is 3.3636, then I can calculate XC, because XC is going to be E over IXC, and so it is going to be 120 over 3.636, and if I calculate that, I'm going to find out that it's 33 ohms. 120 divided by 3.636 equals 33. Okay, 33 ohms. 33 ohms. And that is, you know, the answer for this right here. You know, in other words, what's happening is these two guys are the same, so they have the same current, so they're canceling each other out, and all you have is I total, and, you know, happens to be the same as IR. And that's the hard part from this question, guys, figuring that out. The only way to figure it out is to draw the stuff out. You know, if you're relying on just visualizing in your head, it's going to be really tough, okay? And that's why I always say, draw the circuits if there isn't a circuit, you know, drawn for you, and definitely draw the currents, because the currents are going to help you visualize what's going on here. Calculate the value of the capacitor in microfarads. Well, we know that F, you know, it's going to be this formula right here, right, guys? XC is equal to 1 over 2 pi FC. But if I transpose that for F, I'm going to get 1 over 2 pi XCC, right? It's 1 over all the other things. And so it's going to be 1 over 2 times pi times 33 times, what am I doing here? Please forgive me. Okay, let's try that again. We're going to solve for C here, guys. All right, guys. So where am I going to do that? Right up here, okay? Not here. C is equal to 1 over 2 pi XC. Am I doing this right now? F, yeah, I am. So it's 1 over 2 times pi times 33 times the frequency, 60. All right, and we're going to calculate that. I make a lot of mistakes. You probably noticed that, right, guys? And, you know, just the same as if I was doing it on the board. Okay, guys, I'd make mistakes there too. Looks like it's 8.038 times 10 to the negative 5, which is 0.00008. Yeah. Which is 80 microfarads, okay, because that's farads, right, guys? So that's how we calculate that guy. Real quick, we'll calculate this one. Hopefully I won't make a mistake here. That's going to use the formula XL is equal to 2 pi FL, but we're going to solve for L. So L is going to be XL over 2 pi F. And so it's going to be 33 over 2 times pi times 60. And that is 33 divided by 2 times pi times 60. 315. And then I go 33, divide that by that answer. What am I doing around here? 2 times pi times 60 equals, and then 33 divided by that equals 0.0875 henries. All right, guys? I have no idea what I did the last time. Like I said, I make plenty of mistakes. Okay, guys? Calculate the phase angle of the circuit. Okay, guys? And what do you guys think? Huh? There's the phase angle right there. 0 degrees. So this circuit is in phase. Have a good one, guys.